Let's look at the sixth question. We've been asked to print a multi-line string. Here I'm using triple quotes to start and end the string. The exercise asks us to print the string such that P, E, A, C and E are vertically aligned. Let's now look at the output of the program. To run the file, use the Python command followed by the path to the file. So as we execute it, we see that P, E, A, C and E are aligned. The seventh question consists of two parts. Both of them ask us to print certain images onto the screen. Here's how to get this done. A gentle reminder here that you will not be asked such questions in the exam, but here's how you get it done. There's just some text inside, again, a triple quoted string, 7a and 7b. Let's now run each of the programs. 7b, here we go, and here's 7a. Here's question 11. Get the perimeter from the user and print the side of the square. We know that the relationship between the perimeter and side of a square is side times 4 is the perimeter. So the first step is to get the input from the user using the input function and then convert it to a float, because you can have the perimeter of a square like say 10.25 or something like that. After that, print the side of the square here. One interesting thing that you'll notice here is I've used an F string here. This is a new feature in Python wherein it is possible to embed the values directly inside the string without using any additional formatting options. The only requirement is when you introduce a variable, you want to enclose it within curly braces. So let's run this. Let me enter the perimeter of the square to be say 16. Side of the square is 4. Before moving on to the next question, let's look at a few places where this program can go wrong. The first thing is when the user enters a string like say ABC, the passing of float is going to fail because it's not a floating point input. So the program is going to exit. Similarly, if a user was to enter a negative number, say -100, the program would happily print the value saying the side of a square with perimeter -100 is -25. Let us now see how to make the code robust. Don't worry about it if you don't understand the constructs like while, try, if, else, break, and except. We'll cover these in later chapters. For now, just understand the program flow on how to write a robust piece of code. We collect the input from the user, asking them to key in the perimeter. We try to pass it into a float. If they enter a value say +100 or -100, that's going to be a float, so we'll get the assignment right back into the variable called perimeter. If they enter a string like ABC, that's not a float, so it's going to raise an error, a value error to be precise. We inform the user that perimeter should be numeric, and we got a string which is ABC as the user entered, and we go back to asking the user for user input. Now let's just say that the user entered -100. We'll check if perimeter is greater than or equal to 0. Clearly it's negative, so we'll inform the user that perimeter should be non-negative and go back to collecting the input. If the user enters a value say 100, it passes this particular check, and we inform the user that the side of the square with perimeter 100 is 25, and we exit the program sanely. Let's see this in action. For the first attempt, let's enter the value of the perimeter as say QW. As expected, we get a notification that the perimeter should be numeric. Now let's try the next case. Again, we've got information that it should be non-negative. Third try. Side of the square with perimeter 100 is 25. For the 12th question, we are given the information in feet and we are asked to convert it to yards and miles. The conversion formulas are also given. So all we have to do is divide feet by 3 to compute yards and divide yards by 1760 to get miles. Finally, we print our results. Here's the output. Let's now turn our attention to the 13th question. We are given the sides of a triangular field, which is 30, 25 and 35. We're informed that the total distance covered, say assume that someone is running around the triangular field and they have covered a total distance of 560 units. Now we are asked to find the number of times they have completed going around the triangular field. So this is going to be a floor division. So to simplify our discussion, assume that you have covered 560 meters and the sum of sides of the triangular field is 100. So you would have covered 5.6 rounds around the triangle and the number of completed rounds would be just 5. So that's what this problem is asking us to find. So when we run the program, we find that we've completed 6 rounds around the triangular field. Here's a fun one. The 14th problem asks us to get as input a year from the user and print the number of seconds in the year. A leap year consists of 366 days and a non-leap year consists of 365 days. This is known to us. Python has a built-in module called calendar. A module is just a Python file containing a bunch of constants and functions. IsLeap is of interest to us because it returns true if the given year is a leap year and false otherwise. Don't worry about the location of this file yet. We'll cover this later. For now, we'll just make use of this function calendar.isLeap, wherein it takes a year as a parameter and then returns a number of days. We'll multiply this by 24 to get the number of hours, multiply by 60 to get the number of minutes, and another 60 to get the number of seconds. Finally, display the result to the user. Here's a demo for 1900. 1900 has these many seconds. This brings us to the end of part 2 in chapter 1. Let us now look at part 3 of chapter 1. We'll start with the 6th question. We're asked to print the Fahrenheit and the corresponding Celsius values for the Fahrenheit range 0 through 100, both endpoints included. So here is how the for loop construct works. You have the keyword for followed by a variable name which can be referenced inside this block of code. Then you have in, which is another keyword. Following that, we can have a sequence. Range will also produce a sequence of values. Range is a Python built-in. If this first parameter, Fahrenheit start, is not given, then the default value is 0. If it is provided, you can always provide any other value, like say 10 or whatever it is. As indicated in the comment, the end value is exclusive. That is why we have a Fahrenheit end plus 1. So when you specify a range of 0 to 101, it's going to provide values from 0 to 100, endpoints included. We then make use of the round Python built-in function to round this expression to 2 decimal places. Finally, we use an F string to print the output. Let's see the output here. So as one might expect, values from 0 all the way to 100 are produced. One thing you'll notice here is the step size is 1. That is, say you consider a value like 86, then you get 87, 88, 89 and so on. Say you want to produce the values only for every 3 steps. So you specify comma 3, and when you rerun the program again, you'll notice that you get 75 and then 78, 81 and so on. So the last parameter is the step size. Again, alright, let's now look at the 7th question. We've been asked to print this Ascii art. One thing you'll notice is the first row and the last row are completely filled with the star and the space pattern, whereas the rest of them have just one entry per row. A thing to notice here is all stars are vertically aligned properly except for this one. So care has to be taken to account for this difference. Let's now see how to make this happen. Here's the code. We have num rows equal to 8. So change this number and you'll see the figure vary in size. So this is to account for the very first and the last rows. You see the pattern here wherein these are completely filled. That's what the snippet does. Checks if the row is 1 or it's the last row. See the range here. It starts from 1 and goes all the way to num rows plus 1. If the column that we're printing on is an even number, then we print a star followed by a space if it is not the last entry that's being printed. If not, we just print a new line. Remember that this is going to print two new lines because this is a new line by itself, and end, if we don't specify one, is also a new line, so it will end up printing two new lines. Looking at the diagonal entries, this is the snippet that addresses the code. So again, we'll look for row 2 in particular because, as mentioned before, this star is not aligned properly to this star, whereas this star aligns with this one, similarly this one with this one, and so on. So we'll account for that and print accordingly. The rest of them are self-explanatory. That's about it as far as the 7th program is concerned. Let's now look at 8a. This is the pattern that we've been asked to print. You'll notice that the number of stars keep decreasing as we go down. So here's how you do it. Again, you can configure the number of rows and see the output vary accordingly. As one might expect, there are two for loops, rows and columns. When you print each column entry, you end it with a space, and eventually a print by itself will print a new line. Every time you print a column, the next time you want the number of columns to go down by 1. You want this to be the last star that gets printed. So that's what this numCols equals numCols minus 1 does. Let's look at 8b now. This is the output that we're supposed to produce. Notice that on the top half we have the stars aligned to the right. It's basically a square pushed to the right. Then we have a new line followed by a square that's aligned to the left. Let's see how to get this done. If you look at this square side parameter, it's configurable. Depending upon the value, the number of rows, rather the number of stars that get printed will get configured. So here we have 5, which is why you see 5 stars here. This snippet prints the top half. So when the column that you're printing is less than the square side, that's less than 5 basically, you print a space. If not, you print a star. Followed that, you get a new line. Follow that and you get the left side of the figure. As long as the column is less than the square side, you keep printing your stars along with the space. If not, you just print blanks. That's about it. Before we start looking at 8c, I'd like to jog your memories about two constructs shown here on the right. The first thing is a way for you to create a list using a technique called list comprehension. So what this does is it creates a list of 10 stars because we have star for underscore and range of 10. The reason for using this variable called underscore instead of a variable say like I is very simple. We don't care because we don't make use of this variable. In Python, it's custom to name such variables as underscore. You can name it as anything you want. So as you might expect here, the interpreter spits out a list with 10 stars. The next construct that I'd like to share with you is this one, a string.join of an iterable. So this is a string, comma, and the join takes a list here as a parameter. The list consists of 3 elements, A, B, and C. What join does is it takes each element of the list and separates it by the string here. So that's why you see the output as A, B, C. Now that we have a grounding on what these constructs mean, let's move on to 8C. Looking at the output here, you'll notice that the first and the last rows are fully made of stars. Consider the second row. It has the 2 stars in the middle spaced out. There are no stars here, they just spaces blanks here. If you look at the very next row, we have 2 more stars blanked out. So each successive row gets 2 stars blanked out. So I consider till this position as the top half, and after that we have the bottom half. So let's see how to get this done. We create a buffer with all the stars and print it immediately. So this will give us the first row, and this is the code to print the top half that ends here. So each time, so the first time we have start equals 4 and end equals 5. So these 2 places will get spaces instead of a star. And again we use the space.join, so that's going to concatenate the contents of the buffer and we'll get this. We keep proceeding till the time we reach this particular row. After that we move on to the bottom half. We do just the inverse of it. The very first time we print just these 2 stars. The next time we increment start by 1 and then end we decrement by 1 while we fill them with stars, and we get this particular row. We continue till the time we get back all the stars. So that's 8C for you.